Hello everyone, this is Vijay Reddy Pininti. Today I am going to explain about my project Real-Time Number Plate Blurring. The project is built using YOLO V9 and a few other libraries in OpenCV. As the name of the project suggests, we capture number plates of vehicles in real time and blur them for privacy concerns. An example use case can be when a travel vlogger records his entire surroundings as part of his vlog. The vlogs may capture sensitive information like number plates of vehicles owned by other people. Rather than the vlogger editing the video at a later stage and blurring the number plates, wouldn't it be easier if you can blur the number plates on spot? This idea really stuck my mind and hence I chose this project. Coming to the state of the art, I have identified a few projects which can detect number plates and possibly blur them but not in real time. And also the quality at which they are getting the job done is really questionable. Hence I chose to use the advanced state of the art technology YOLO V9. I'll simplify this paper for you. YOLO V9 or You Only Look Once version 9 is a powerful real time object detection algorithm. It can detect objects like cars, people, animals, and license plates, etc., in images or videos very quickly and accurately. With YOLO, you don't need to scan the image piece by piece. Instead, it looks at the whole image at once, which makes it much faster than older methods. But why use YOLO V9? Because it processes the whole image at once. It can detect images in real time like live video feeds. It can detect multiple small, large, close, and far away objects in the same image with high accuracy. YOLO models are popular in applications like self-driving cars, surveillance, etc. So how YOLO V9 exactly works is it takes an input image or a video frame, it divides the image into a grid like chessboard. For each grid in the square, it predicts if an object is inside the square, the position and size of the object, the type of object like car, person or license plate, etc. While these can be the pros of YOLO V9, there are a little cons as well because sometimes it misses very tiny objects and far away objects. It if too many objects are close together, it might mix them up. To run YOLO fast, you need a GPU. I myself had to purchase Google Colab Pro to implement this project, but it's worth it. It can use a lot of memory on large images or videos. That being said about YOLO V9, let's dig into the project. So let's go step by step. Yeah. So firstly, I've imported the required libraries, and then I've basically cloned YOLO V9 the implementation, and we have installed the required libraries for this. And then since we are training our dataset with custom configurations and not using the predefined dataset provided by YOLO V9, I have made a certain configurations and all, and this basically moves all those configurations into the YOLO V9 folder. Once the data and configurations are set, we're all ready to implement it. So this particular function called train model, this function basically implements the uh, train dual.py which is provided by YOLO V9. Uh, we are using that and we are setting the number of workers, and device 0 basically means CUDA, and we are setting the batch size and we are telling it how many number of epochs, and we are telling that the image size would be 640 because YOLO V9 is pre-trained on 640, and we are not training this model from scratch. We are using pre-trained weights of YOLO V9 which are available in the GitHub repository. Let me show it quickly. Yeah, so this is the GitHub repository and implementation of YOLO V9. So I've used this repository, and if you go into this tag here called releases, here all the pre-trained weights are available. From this I've used YOLO V9 e.pt this as my base weights, and as I said, I'm not training it from the scratch. So using those weights, I have trained my model. And once the training is finished, so we can like I've done experimenting with different types of epochs. So once the training is completed, so I'm it would basically go into this folder called runs, and inside runs you'll have called folder called train, and inside train you'll have experiment folder. So what I'm doing is, so I'm basically extracting this uh, folder and copying it into a newer directory, and I'm adding a suffix with the number of epochs on which the data was trained. So I have trained the model for 50, 100, 150, 200, 250. So basically in the range of 50 to 50, 250, with an interval gap of 50 epochs. And we have the results here. So let us quickly look into those results. Yeah. If we look at the results, training losses show some reduction but are relatively high. The validation losses are still stagnant. Precision recall and map matrices are unstable. So I've decided to further proceed with my training, and I've trained the model for 100 epochs. And if we look at the results, the training losses continue to decrease compared to the previous training, but the validation losses still remain stagnant. Also, the map matrices still show fluctuations, and precision and recall have improved a little bit. So I've still went further and trained it for 150 epochs. If you see, the training losses decreased furthermore, but the map matrices does not have the stability which is required. So I've decided to give it a bit more training. Again, the training losses decrease steadily. Precision and recall values are close to 1, and map matrices are steady within the range of 0.75. Uh, I mean, these are good results, but I wanted to see if the model is overfitting, and I've trained it further for 250 epochs. Uh, if we look at the 250 epochs, there is no much improvement in the results compared to the previous training of 200. So it was kind of a tie between 150 and 200, and I've went ahead and chose 250 epochs as my base model. So after choosing my base model, yeah, I've written this function in image, blur number plate in image. So this code is pretty simple. Firstly, we are loading the model. So as I've suggested, I've went ahead and chose 200 as my base model, and I've chosen those weights. Okay, and if you look at this function, this is pretty simple. This function expects the image and the model weights. Okay, so the image basically means the image which we want to blur. So I've taken the image, I've detected the the four borders of the license plate, and I've extracted the confidence. So if the model is able to detect the license plate with a confidence of at least 0.5, I've marked that region. Once the region is marked, we are blurring the number plate using Gaussian blur, and finally we are overriding the previous image with this blurred image, and we are returning the image. So this is as simple as such. We'll look at a demo later while using the UI. Similarly, when we come to the video part, so for video, we are using cv2.video capture. So this function basically accepts the uh, input video, the output video, and the model. So we are providing the video to it. We are getting the frame width, height, the frames per second, and the type of encoding the video we need to produce. So this progress bar is for you. I'll later show you why this is exactly required. And we are getting the maximum number of frames present in our video, and also we have initialized a variable called frame. So uh, first, what we are trying to see is if the provided video is an actual video or not. Okay, if we provided if we does not if we don't provide the input video, we should throw an error. And so this is what we are doing. So if video is openable, uh, if video is not openable, we are returning the error message, and we are stopping the execution here if we have a proper video. And then we also provide a output part, like where we exactly want to store this video. Okay, so we are checking if the output directory already exists. If it does not exist, we are creating a directory for it. And once the directory is created, we are using this video writer function from cv uh, to write the blurred video. Okay, so basically what we are doing is we are again, we are getting the video, and we are getting the frame from the video. And uh, once we get the frame, we are passing that frame to this function, basically again the blur number plates function, the frame and the model which we again generated above. And once basically we'll get back a blurred image, and we are writing that to the video. Again, as I said, I'll explain about the progress part in the UI part. And once the entire video is generated, like once the entire video is processed, all the frames in the video are processed, we'll release the media and the output. Okay, now let us look at a demo. Okay, so we can run the UI by using Streamlit. So we basically say Streamlit run app.py. Application is up and running. So this is pretty simple UI. We just have a input allowing us to upload a image file or a video file. So I'll just click on browse. I'll select any of the image, like you can select any of the image. So let's go with this image. Click on open. Click on submit. Once you click on submit, it first shows you the original image which was uploaded. After that, if you can see, it gives you the blurred image. Okay, and you can simply click on this blurred image download button, and it gives you the option to save it. I'm not going to save it, but yeah, or yeah, you can just save it. And yeah, this is your saved image. Similarly, you can upload a video. I have it here. I'm going to upload a video. Click on submit. So when we spoke earlier about this progress bar, that is for this part. So uh, processing the video on your CPU takes a lot of time. So that is why I've given this progress bar. If you are using a CUDA machine, then the processing time is much more faster. But still, at the end, it's good to know the progress of your application. This, if you're running on your CUDA, I have a 21-second video, and it takes somewhere around 1 hour. uh, yeah, we'll look we'll look at the results directly. So the main agenda of the project is to blur the number plates in real time. So for this, what I've done is I've taken some images inside my mobile. So this is just a test environment of how the model would actually perform in a real world. So I have the images ready in my mobile, but before that, let us quickly look into the code. So what happens is we are capturing, so video capture dot zero basically means we are telling the model to access the content from the camera enabled in the device, and if the model is not able to open the camera, we are just going to return an error and stop the process then and there, like we cannot open the webcam. But if we are able to open the camera, we are going to read the frames from the webcam, and from that we are telling the model to process or blur the license plates. And once we receive a keyboard interruption, we are going to stop that. So let us look into this quickly. So we can just say Python blur number plate in webcam. So there is no CUDA enabled in my local device. So this is just so it's little, the camera takes little time to load and process what's there in the image. So yeah, let us wait for the model to load. Yep. So the camera is enabled now. As I said, since I'm not using CUDA enabled device, it's struggling a little. So as you can see, currently it's my normal phase. So the model is not blurring anything as of now. So now what I'll do is I'll just show the model a few images of license plates, and let us see what the model will try to do. So here I'll be holding a image close to the camera. Yeah. Let us just give it some time. Yeah, as you can see, the license plate got blurred. So that's about my project. Thank you. Thanks for watching my video. So that's about my project. Thank you. Thanks for watching my video.